So last talk for tonight is the distant third cousin 3 times removed, Karl Roberts.
We're good? All right. Hi, everyone. Can everyone hear me? I've got the Lisper mic on tonight. I don't know if you've noticed everyone who wears this ends up lisping. I don't know if you've... Anyway, just me. Right. So we've had, ScalaSyd FP dressed up as Scala tonight in the first talk. We've had some deep looking into how it does what it does in the second talk. So this hopefully is the antidote to that. Where we don't go too deep, we don't go too thoughtful. But it also might be the antidote for you new Scala people here when you go, what the hell is going on? Anyway. So, how I invented lenses. Crap. Okay, so just quick thing to begin with. I now work at Avocado, which is a consultancy just around the corner. We do have jobs, didn't mention this earlier. They're not specifically Scala jobs, but I want people who care about delivery of stuff. If anybody cares about delivery, come on and have a look. So first of all, what is a lens? Well, obviously, you just use it to set fire things. I mean, that's all I ever used them for. But really, it's about focusing on stuff. And in fact, importantly, different lenses will focus on different points. And that is, whenever you hear people talking about these or reading about it in the ScalaSyd stuff or any of those things, that's the main point. It's just that they're a way of focusing on a different place, hopefully easily. So what's the problem? Okay. So say we got this nested data structure here. These are really common. A person might have an address might have a street might have numbers, I don't know. And typically in Scala, we'd write a case class, which we now know is going to be inefficient. But we'd write these case classes to handle the bits, and we can nest it, and we can build up this complex data structure that's all nice, and we can compile it and jump in and deconstruct it badly, to find out what we're going. But if we had this particular one here, what if I wanted to modify V if I had the A? All right. So we can see I need to get to the B, then get to the C, then get to the D, then get to the E and change its value. In an immutable world, this is easy, right? Just wouldn't even think about it. Functionally, if I had that with a case class in Scala, what's going to happen to me? I'm going to write all of this. So, I mean, this is worth noticing, going from that to that is a boilerplate FP fail, we can't have that. We're in ScalaSyd here. We've got to make Scala better than Java. So a lens is a pattern to remove all that cruft. That's basically it. We just want to focus on the bit we want to change and change it. So I better get to the topic. So how I invented these. Well, you might recognize the ship, but I didn't invent them. I discovered them. Like all of this stuff, it's a voyage of discovery, and many people have been there already. So, it's worth using what they do. But quite often, and this is the main motivation I did this talk, is someone will go, oh, monad. It's monad. Solve it with monad, Oh, co-monad with a functor, Yeah. It's like, well, what the hell are they talking about? And why do they care? This stuff, if I had my object-oriented code in Java, I'd just go to the thing and change it, and nobody would, no one would be any the wiser. It'd be good. But I think part of the reason why you want to have this voyage of discovery is to find where these patterns actually start to become useful to you. So, your propositions as types, is useful to Jed now. He's going to go on and write the next compiler or something. But in these cases here, you might want to there's a lot of people come into this stuff and they go, well, I'm not going to listen to you. It's all too hard. You're talking nonsense. But this is just to show you how all this stuff is really just how all the math is. It's a discovery of the patterns that intrinsically hold all the time. So this is just one of the simplest ones, hence it's the talk I've done. But apply this to your monads, same thing will happen. Right. So, as I said, I haven't discovered them. I discovered them, and other people have discovered them too. There's a thing we'll see. But what was I doing? This is obviously made up, but what was I doing to find all these things? Well, I was working on a thing called ScalaCast, which is a scalar wrapper to use in Hazelcast. I was asked to do a talk for Hugs by the Hazelcast guys when we were partners with those. I didn't want to do the talk, so I thought, well, I'm going to do the talk. I'm going to write a library and talk about that instead. It was a bit of a joke, but it worked. It was fun, and it got got me diving into some of these silly things and where the rubber hits the road in the Java scalar divide. So I was working on this thing. It was purely for fun, and I got sick of the config. And I don't know if anyone's used Hazelcast here. So the config file, you can't even see it, and that's the point. We've got thousands of these. They just go deep, 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 and each one is nested. In fact, it's kind of super nested. Each property is nested. It has a fluent DSL, which is the good thing about it. The fluent DSL. I don't know what language you're fluent in when you write this DSL, but it's there. Or you can use the XML config. But the fluent DSL is kind of inconsistent as well. So, for instance, we have things like this going on. Others, just literally return void, so the fluency stops halfway through. Instead of it's pretty tricky. So I was getting sick of this. And I just wanted to do something really, really simple. Like Hazelcast, I should mention, is a distributed cache or a grid. One of the things you might want to do with any cache is write it down to its persistent back end or something like that. So typically you can just say on this map, right through, semantics will work. Every time I save something, I know it's there, et cetera, et cetera. So it allows you to do this. But this is just right through on my map. I've got to jump through a number of things here. I've got to get to the config, get the map config out of the config, give it a name of which map I'm after. From that map config, get the map store config. It might be null, So I've got to check for that, and then else, if it isn't null, then I can set my thing. Finally, I then have to set it back up, and it's all, This is the kind of thing that happens all the time, and it will lead you to write this stuff or not. So obviously, I now have to write my own DSL. I want something like this. This will be good. I want to be able to go, given the config, on map through, enable write through. That's one of my most common things that I want to be able to do. Just do that. Yeah. So that's a talk for another day. I'm not going through type classes and all the pimping that's necessary. I'm just going to concentrate on the bit where we're looking at this really simple abstraction, the lens. Okay, so my lens evolution. I'm going to start at the start and show you how I got there, how I invented them, discovered them. In order to do, has anyone here written a fluid DSL or know what I'm talking about here? Yeah, so they're awesome, right? Basically, you want to say, I want to do this, and do this on it, 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 so that it every time has to kind of be returned. So that you've got the structure to then run the next function on, and if you jump out of that structure, it needs to somehow have a way of coming back to the beginning again, and all kinds of join-ups if you want your syntax to be fluent. So obviously, it's a functional language. It's going to be done with a function. In this case, you might write a function from config to config. So this is my basic type, I guess. Given the config, fiddle the map. and then on this bit of the config, do this, and then on this bit, do this. I'll keep getting back to my same superstructure. So I can compose these things forever, given a big enough memory pool. So here's my start of it. I thought I'll start out, I'll just, it's boilerplatey and whatever, but it's a library, and if, just get this stuff out of the way, we'll never have to look at it again. Then someone will make you do a talk on it. And as you can see, it's for the executor config, I wanted to do a thing and pass in a function that, given the executor config, would give me the executor config, and given the group config, would give me the group config. This just shows you how complex this config is, right? It's a silly thing. Oops, I jumped to the end. But a bit of a shameless plug there while we're at it, I suppose. So I'm actually doing a boxing match on the 5th of December. If anybody wants tickets to see me go up against these fucking massive bastards, just see me at the end. Let me see if I can find the beginning of where I was again. Okay. Yeah. Okay, so if I have a look at this, for instance, the enable multicast one, for instance, I might say enable, took a Boolean in there. I want the return type to be another config to config. I can do something where I go do networky config, do the thing, return the thing. I mean, that's basically what you're doing in Java anyway. I'm just literally repeating it and mashing it so that it becomes a function, so that I can then compose these things. Notice the mutated thing in there. ScalaCast has inconsistent mutation going on the config as well. So occasionally, it also, in getting, sets it, and vice versa, and other stuff like that. So, I didn't need to return it, but thinking functionally, I thought I need to return a value. I'm gonna do this kind of stuff. Okay. Similarly, so that was enable multicast. There was another do network config thing that I wanted to do. It's pretty similar again. Again, we've got the confused mutation going on where, actually getting the thing sets the thing. So, help yourself. And again, this is becoming pretty regular. It's pretty similar what I'm doing here. I'm taking the config in, fiddling with it, and returning it. So clearly, this can be refactored. So I can simplify this with a combinator called doit, which allows that, which, it's obviously true. I'm not going to let you read it, but actually I will let you read it. But basically what I'm saying here is, to modify a value with a function, we need a function, f that to change the thing inside. We need to be able to get the thing we want to change, which would look like that. Given a config, get the A out of it. And then we need to be able to set the thing as well. So, I need to be able to apply that F on the A that I've got back from the C. No doubt we can write this as a propositional type now, and I'll be asking questions afterwards. No? So it's pretty easy. And then you just simply join it all together. So mod is simply get the thing from the config, run the change on it, and then set the thing back in, given the config. And there you go, that's it solved, almost. But what about the complex ones? That was fairly trivial if you're one level nested deep. It's not too bad. But if you think what I'm doing here, if we go back to this function here, do it, get network config, set network config, or whatever, for network config. Well, what about, I've got network config and I need to get the foo config out of it and do something at the C config down in the foo config, and, now I could obviously do this with taking my functions and composing them, but anyone's been around any amount of time, you realize that as soon as you're talking functional composition, you want to have a look around and see if anybody's given you a neater syntax for doing function composition rather than nesting these parameters out. It starts to get pretty twisted. So obviously I look around, and what did I see? Well, do you remember that from the beginning on the ship? I saw that guy. Well, that's actually my one. And that one from on the ship, well, that's pretty samey, getting a set and a thing, but they've somehow magically left out the rest of it. But let's have a look at this. This is my voyage of discovery, and obviously it lived in this library. So ScalaSyd has done this for me already. Someone's tread this board and stamped out some answers for me. And it also comes with a pretty big API. So, hopefully there's some nice stuff that I can use out of this so I don't have to twist all my functions into knots. The API, goes on for, a while. But you can see you've got the ability to modify the thing. So I can take I've got a mod function on it, basically. I can mod with a functor. But also, importantly, I can compose it. And that's the bit that I really cared about. So given a lens to one place, I should be able to compose it with another one to get to the place that it was pointing to. So that whole stack of walking down from one config to the other just needs a lens from somewhere to somewhere. And if I want to go deeper, another lens from that place to that place. I don't have to care about that one. I can just do these bits in isolation and then glue them together. And obviously this, if you see this pattern, by the way, and you will, I've got a data type lens, and it's effectively just wrapping functions. It's the constructor of this thing is that Mark Hibbard quite often tell you, wherever you can, wrap your functions in a type, then you can apply an API to it. And that's exactly what has happened here. They've taken a function, hidden it inside a type called lens, which they can use anywhere, and then they can just write all these extra functions or extra API calls outside that work on the initial one. But it's still a function, so it can still be glued in some manner. There's my boxing again. I don't know how I keep doing that. You guys, sure you don't want to come here? Right. Okay. I'll get back to here. So how do you actually use them? Like ScalaSyd, one of the biggest complaints you'll get is, yeah, it looks really clever, but I can't even read the description of how to use it. So, how do I, I'm not going to bother, I'm going to use Java. But I mean, this one's actually not too bad. You have to go digging all the way down through the thing until you find the thing called lens U, or I think that presumably means lens update. It doesn't really say on it. There's some description in there. But basically, what it lets me do is take the left-hand type, so I can take a config to the network config, because network config is somewhere inside or nested inside it. And in this case, it's nested one level inside it, but I could have 5 levels inside. So this lens is a lens from focusing from the config to the network config. And all I have to supply it with is, a setter and a getter. That's exactly what I was doing before, except now I can just break it out. So here you can see you've got my lens, my network config, my join config, my multicast config. And interestingly, I can go config to network config to join config to multicast config, and finally set the value, right, somewhere down there. So I can compose these things without getting all twisted up. So here's an example. To enable the multicast, which needs to do exactly what I just said, and then run set enabled, it becomes this, right? So not too bad, pretty straightforward. Quite a few fish swimming around in there. But, wouldn't be scalar unless we had symbolic functional names, would it? I mean, you've got to have those things. That just means and then, and that's the alias for the mod in the thing. So not too bad. I can say one lens, how do I do my thing? And I just provide it the getter and the setter. Take another lens, the getter and the setter, another lens, the getter and the setter, and then just go fish, 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 change. So all good. So coming to the end, I've obviously solved everything now. But there were some problems, and the problems, if you go and have the code is out there, you can go and have a look at the problems. But if you imagine that config structure that I had out there, this was hundreds of nested configs. Each one of those, that first one was the top level that you saw, and there was like 50 of them. Inside of them, there's like 5 or 6 on each one at least. This is a ridiculous thing. If I wanted to do this with lenses, I'd have to have a path for every possible thing that I'd want to change if it was a library with DSL. And that's basically makes the Cartesian product of every single lens walk that I'd want to do, which I don't really want to do. Also, the underlying data structure that I was just messing with here to get it, mashing it around, is mutable. Lens is obviously a pattern for functional programming, and it works better with immutable types. There's some wacky stuff happens. It actually passes the lens laws to some level on the tests that I was doing with it anyway. Like, I'm sure if I start doing some more twisted things, it would mess it up. But it would be a lot better, I think, if I was to perhaps use a zipper, which is perhaps a talk for someone else in the future, which allows me to just arbitrarily go down, in, change, or do whatever, rather than have a fixed way of getting there. So also it would be better, I think, in this case, to create my own immutable config that was everything that ScalaCast can do, work on it, and then have a function that generates the ScalaCast one from it. That would probably be a lot simpler. And I'll probably do that at some point when people complain about the code that's on the internet. So that's just what I was talking about. So where do we go? So basically, you've got to go back, get on your ship, go and have a look, and keep discovering, because these patterns are useful. As soon as you know what they're for, or worse, better still, you've actually tried something, and then just keep refactoring back out and go, this is stupid, I shouldn't be doing this. Look, these look similar. Let's extract it to a higher order function. Let's do this. Eventually, with a lot of these things, especially if you keep them pure, you'll come back to, I don't know who is it said, that ScalaSyd is the only way to write some of these things. If you keep refactoring backwards to the more general case that still type checks, there's usually only one way to write it, and that is the way that ScalaSyd's already done it, so you might as well just use their library. Plus some of the people are around, we can actually ask them how it works. And that's pretty much it. So thank you very much. Any questions? So, yeah.
Just on the proliferation of boilerplate.
Yep.
So there are 2 approaches that can help, which is macros and generic programming, and the monocle library and the shapeless library both have both of those, which you may...
Which library, say?
Monocle.
Okay.
It's a lens library, and shapeless is a library for generic programming. And both of, they might be interesting to explore.
Thank you very much. I'm pretty sure. I mean, like I said, this was doing it for fun, just to almost hit the knots and twirls, just so I could get a better handle on it and realize that I didn't want to do that way again. But so monocle and...
It means they write the lens for you.
Yes, cool.
Just on that, the monocle library, I think, is the one everyone's using, as opposed to ScalaSyd's one. So I think it's called Van Leeuwenhoek lenses. It's a particular formation. It just turns out to be easier to use.
Cool.
That's all. Right. It's more, actually, I'm not sure it's easier to use, but it's more general. And so therefore has more application. But yeah, it's
but like with
basically
all these
the
things,
same thing.
Like with all these things, find the right pattern for your problem, I guess.
Well, it's the same pattern. It's just a slightly different formation. And so there are things called prisms, which are to do with the optional thing, and then lenses. So, and it's, I think it's just about the fact that it's more general. So you can compose them in more
Better
interesting ways.
Cool.
I think the thing that was interesting to me was that you're asking, well, Hazelcast and any config API is asking the caller to understand the data structures underneath and,
That's right.
and break encapsulation, and there's no information hiding. So given an A, I want to change a V that's 7 levels down. That's preposterous, right? So maybe the solution is also to think about reducing that complex depth and reducing the amount of understanding of that complexity that needs to be had by the caller. Sure, as the library writer, you may want to do that, and that's fine. And you providing a DSL
For myself.
gives the callers an out to not have to worry about that. But as you say, when you've got all these different types in the data structure of the config and all these different properties, then providing a path for each of them becomes quite difficult. So it's just, I suppose, stepping back and thinking, how can I avoid the problem in the first place?
I mean, like, I'm being slightly unfair to Hazelcast here.
They're no different to loggers or anybody else.
Their default config was written in XML for Java land in XML days. And then they've basically just replicated it in a programmatic manner. And there are if you use it, there are a bunch of defaults that are already in place, so you don't have to navigate most of it. But then you come across these weird things, like just setting right through becomes, 10 lines of code. But
the interesting thing too is that in creating a statically typed structure from data that's non-fungible, really, like your config doesn't change typically, right? It's pretty much that's it. It's not like a domain model where you could have that user or that user. It's like that's the network config.
Yep.
It's not going to be different, but we're still programming against it as if it's